In this video, I'm going to explain to you how to sketch hyperbolas. So our first example is sketch the graph of y equals 2 over x plus 3. Now remember, every hyperbola has two asymptotes, so the first thing you want to sketch is the asymptotes. Okay, so write down the equations. So asymptotes, okay, our vertical asymptote has the equation x equals, in this case, the value that would make the fraction undefined, which is 0. Our horizontal asymptote has the equation y equals the q value, which is 3. So once you understand what the equations of your asymptotes are, sketch them. And we sketch asymptotes as dashed lines. So I have an asymptote as at y equals 3. And label it. Okay, so y equals 3. Then I have an asymptote at x equals 0, which happens to be my y-axis, but I'm still going to indicate it with dashed line and label it. Okay, now those asymptotes cut the plane into 4 quadrants. Okay, so I see that my a value is positive, so I know that my graph will lie in this first and the third quadrant. Okay, so the next thing we want to sketch is the intercepts with the graph. Now, since the y-axis is an asymptote, I can know straight away that I will not have a y-intercept, but I can find the x-intercepts. So to find the x-intercept, I'm going to let y equal 0, so I have 0 equals 2 over x plus 3. This is an equation with a fraction, so I'm going to multiply by the denominator. So 0 times x is 0, 2 over x times x is 2, plus 3 times x is 3x. Solving for x, subtract 2, divide by 3, and I have x equals negative 2 over 3. So where x is negative 2 over 3, y is 0, and I can plot that. So that's negative 2/3. So 2/3 of the way to negative 1. Okay, right, so then I can find extra coordinates. So I would like some coordinates in the fourth quadrant here. So I could choose negative 2, negative 3, negative 4 as my x values. And I need some coordinates for the first quadrant. So I'm going to choose x is 1, x is 2, x is 3, and so forth. Now you are welcome to use your calculator to give you a table of values, or you can do the old-fashioned calculation. But it is a waste of time in an assessment, so use your calculator. But yes, table of values, okay, and I want some on both sides of my vertical asymptotes. So if I have x equals negative 3, the value is 2, 3 recurring. Where x is negative 2, the value is 2. Where x is negative 1, the value is 1. Where x is 1, the value is 5. Where x is 2, the value is 4. And where x is 3, the value is 3. And 6 recurring, which is 3,6,7. Okay, so plot these points. So I have negative 3, 2, 3. So that's there. Then I have negative 2, 2. Plot it. Then I have negative 1, 1. Plotted on the graph. Then I have 1, 5. Okay, so 1, 5. Then 2, 4. So 2, 4. Then 3 and 3,6,7. So 3 and 3,6,7. Okay, so those are some coordinates to help you draw an accurate graph, but it is really your knowledge of the shape of the hyperbola that is going to help you draw this graph. So when you draw the arms of the hyperbola, remember that the graph will come from infinitely close to the asymptote, okay, then curve neatly through your points and then continue ever more closer to the asymptote. Okay, so don't curve your graph in like that, which I see students doing. Okay, and then in the first quadrant, come from close to the asymptote through your points and continue going closer and closer to the asymptote. Okay, and that's your first graph. Our second example says sketch the graph of y equals 2 over x plus 1 plus 3. Now you'll notice that the only difference in this equation from the previous one is that we are adding 1 to x in the denominator, which gives us a horizontal shift. In which direction? We are adding 1, so we are going to shift to the left. Okay, let's see this in action. So the first thing we want to sketch is our asymptotes. Now, our vertical asymptote, its equation is if I take the denominator and make it equal to 0, that would make it undefined. So I want to avoid that. So I need to find the x value that would make that undefined. So I solve for x and I find it is -1. So I can sketch a dashed line at x equals -1. Use your ruler, not like this, okay, and label it. Okay, then my horizontal asymptote is y equals the q value, which is 3, and then draw it, dashed lines, and label it. Okay, then I want the intercepts. Now, neither of the axes is an asymptote, so I will have a y-intercept and x-intercept. Okay, so let's first find the x-intercept. So letting y equal 0, I have 0 equals 2 over x plus 1 plus 3, multiply by the denominator. So I have 0 times x plus 1 is 0. Multiplying by the denominator cancels the denominator, plus 3 times the denominator x plus 1. So simplifying this, I have plus 3x plus 3. Solving for x, this is 2 plus 3, so I'm going to subtract 5. So that's 2 plus 3 is 5, subtracting 5, I have -5 equals 3x. Dividing by 3, I have x equals -5 over 3. Okay, so where x is -5 over 3, y is 0. Okay, for my y-intercept, I'm going to let x equal 0. So I have y equals 2 over 0 plus 1 plus 3. That simplifies to 5. So where x is 0, y is 5. Again, okay, so we can plot these points. So 0, 5, there's my y-intercept, and -5 thirds. So that's -1,67. Okay, is my x-intercept. Now that is not enough to sketch the graph. Okay, I can know from the a value that my graph will sit in the first and the third quadrant, but I need more points to draw an accurate graph. For that, you can use your calculator to find a table of values, or you can do manual calculations. Okay, so I want some x values on either side of the asymptote again. So where x is -3, -2, let's do 1, 2, and 3. Okay, so -3, then y is 2, x is -2, y is 1, x is 1, y is 4, where x is 2, y is 3,6, where x is 3, y is 3,5. Okay, plotting these points, so -3, 2, -2, 1, 1, 4, 2, 3,6, see, and 3, 3,5. Okay, and then I can, from my knowledge of what the shape of the graph should be, I can use that and my points to draw a more accurate graph. So from close to the asymptote, curving, and then going close to the other asymptote. Again, close to the asymptote, curving to be close to the other asymptote.